So, this is basically what's on that part 2 test anyways. These two types of problems. And so with this one, what we're going to do is break it down. Factor it. Right? And then what multiplies to be 30, right? But it subtracts to be 7. Right? So what multiplies to be 30?
10 and 3.
10 and 3. So, see how that goes? And then everything else just kind of falls in. The x and the x. And then the signs, that's a little different, right? The sign is plus here. But this tells me that these two signs are different. So this has to be minus, okay? And then once I've got that, the key here is that the bottom cannot be 0. So what makes the bottom 0? What minus 3 is 0? 3, right? So x cannot be 3. Alright, and now we can cancel some things out. Okay? So let's rewrite it. X plus 10, right? Divided or times x minus 3 all over x minus 3. And so what can we cancel?
X minus 3.
The x minus 3. Okay? So we're left with x plus 10, whereas x cannot be 3. And that's it. It's not that bad, right?
Yeah.
The factoring can be tough. Okay? Remember, it's just that 3-step method. What multiplies that? When there's nothing out in front, it's just what multiplies this to whatever this is, subtract or add to be whatever this is. And it's really easy. It's 3 steps. 1, 2, 3. Okay? So again, 3-step method. What multiplies to be this, but it subtracts to be 2. So multiplies to be 8 and subtracts to be 2. 4 and 2. So it's, whoop. And we always put big number first, right? Because that's really important. And then we put in our x's. And then the sign goes up. And this tells me that they are
Same. Are they different?
different. Good. Because the minus tells me difference. Right? Different. Alright, then this guy. Same thing, right? I'm going to go, what multiplies to be 4, but it adds to be 1.
2. 4 and 1? 2 and... Oh, no.
Nothing. It's not factorable. Right? Because it's 2 and 2 and 4 and 1. And so that one's not factorable. So that stays the same. We can't factor it. Okay, so now we're dividing, right? That means none of this can go to 0. None of that can go to 0. Okay? To figure that out, unfortunately, you need quadratic formula. These two are easy. X cannot be -2, -3, right? -3. But to figure this one out, it's quadratic formula, unfortunately. Okay? Now we're going to rewrite this so that we have x minus 4 times x plus 2 over x plus 3 times, and we flip it, x plus 2 times x plus 3. Am I recording?
Bless you. I think you should.
Yeah.
Bless you.
And then all over the x squared minus x plus 4. Okay, and so what can I cancel?
X plus 3.
X plus 3. Okay, so this one's kind of a big answer. X minus 4 times x plus 2 squared over, because there's two of them, right? Over x squared minus x plus 4, whereas x cannot be -2, -3, and then to find the last one, we have to plug in the quadratic formula. So A, B, and C. Okay, so it's going to be -b, so -b plus or minus the square root of b squared minus 4ac all over 2a. And then I have to go, well, what is b? B is -1, -1, right? And then we have, what is a? A is 1 and 1. And what is c? It's 4. Okay? So then I have negative, and negative is a +1 plus or minus the square root of 1 minus 16 over 2. And that tells me it's a complex number, which means it's not real. And all we want is real answers. So therefore, this is you're done. Does that make sense? Because the non-real answers aren't going to come up. Because they're not real. So non-real answers won't come up as asymptotes. So we only want the real numbers. Does that make sense?